Hello and welcome to this introduction to the head modification designed by David Ferreira for the B2-EMO designed by Michael Baddeley. This is a representation of the B2-EMO droid in the Andor Disney Plus series. Before I start talking about the new design of the head mechanism, I'd like to talk about the current design limitations. Now, for the head controls at the moment, there are four 35 kilo servos. There's one 35 kilo servo to lift the head up and down. There is another 35 kilo servo, which is doing the rotation. And then there are two servos used for the head nod and tilt. So four 35 kilo servos in total. The first limitation, as I see it, is that the head rotation is limited to probably about 160 degrees here. It doesn't give the full head rotation that is seen in the series. The next limitation is there is quite a lot of backlash and movement in these servos. These servos are fully powered, but I can quite easily move the foam around. So if you're driving along and remembering you're on Mecanum wheels, which are rattly, the head rattles quite a lot. The next issue is the plane of rotation. So where the Lazy Susan of the head is to give us this rotation, it's actually above the plane of the tilt and nod servos. So if I tilt the head back and then rotate it, the head is still tilted back from where I am standing, but over to the side, it's looking strangely canted to the side like that. So it does make the animation slightly more difficult. As I said, the Dave Ferreira modification as well gives a general stiffness and robustness using higher quality components, aluminium, steel, higher quality servos. The main pros of the replacement design are that the plane of rotation is now moved below the lift, tilt, and nod servos. So that improves the animation capability. It makes it easier because you will be doing an awful lot when you're trying to animate the droid by yourself. I mean, in the show, it took 3 people to animate it. Usually, as hobbyists, we'll have one person animating it. Sometimes some people are using 2. And the other pro is to really stiffen up that mechanism so that there's no rattle or wobble as you're driving along. The cons of the design, the Dave Ferreira design, is the complexity of the design. It is a far more complex design, but it's a relatively straightforward build. Everything pretty much went together as the CAD, and as you'll see in the next couple of videos. Other than having to drill and tap holes and do wiring, there is nothing else. Everything else came and just fitted together perfectly. And that's really a testament to Dave's design capabilities. Secondly, there's the cost implications. It is a much higher cost upgrade in that there are metal plates from Send-Cut Send. There are machine parts from either PCBWay or JLC PCB, whoever you decide to go for. And then there are McMaster-Carr mechanical parts. McMaster-Carr won't ship outside of the United States of America, so that means that if you don't live there, there's going to be a bit of sourcing issues. So finding compatible parts shouldn't be an insurmountable issue, but it will add to the complexity. The last potential issue that I see is that the head mechanism is going to be heavier because it's made out of metal, or a lot of it is made out of metal rather than 3D printed parts. So it's going to move that center of gravity of the droid up further, which may or may not be an issue. That's still to be seen. Okay, so I think I will pick up this video once I have the new head mechanism in there, and we'll see how that works. Okay, we're a number of weeks on now, and I've fully built the head mechanism, inserted it into the droid, built it into there, and had V2 out at 3 different events now, 2-day events each. Absolutely no issues whatsoever with the head mechanism. I'm really happy with it. It seems to be working fantastically well. So just to show you how he works, we'll bring V2 up to his full height. The first issue I had with the original mechanism was the fact that the planar rotation was above the tilt and nod mechanism, which made it a bit strange. When you tilted the head back and rotated, the head would effectively tilt over to the side when seen from the side. Also, the rotation was about 160 degrees. Now, full 360-degree rotation. So that's totally sorted out. Secondly, I talked about the backlash and wobble within the system. Now, wherever I move it to, it stays there. And if I move closer, there's no slack in those servos at all, where there was before. Those are really the main issues I saw with the original head mechanism. This has totally cured them, and I'm really happy with it. So that's a look at how the head mechanism actually works. The next 2 videos will be how I built the head mechanism and how you can do that yourself. I hope you enjoy the series.